Hi, in this video we are going to talk about the mean and the median of a distribution, when to use them and when not to use them. Let's start with our credit dataset and let's select the variable age. Now we can start from here. We are going to right click on the variable and ask for descriptive statistics, and here they are. So we can see that the mean and the median are fairly similar. Let's recall what the mean and the median are. The mean is the expected value of a variable, that is, the sum of all the variables weighted by their probabilities. So it's the typical value or the center of gravity of a distribution. The median, on the other way, is the value that halves the distribution, that divides the distribution in an equal number of values to its left and to its right. When we have the mean and the median so close, this is a signal that the distribution is normal, or that the variable is normally distributed. That is, that its distribution is bell-shaped and symmetric. Let's ask for an histogram to see if this is really true. So we go to Graphs, we ask for histogram, and let's select variable age. We will press OK, and we will see the histogram of a variable. Do you think this is bell-shaped and symmetric? To help us decide, let us overlay a normal distribution curve over this histogram right here. And here is the curve of the normal distribution that we are going to apply to our variable. Well, yes, we can see that the variable is not exactly normal because the histogram is not exactly contained by this curve, but is more or less symmetric, and the center has more frequency of data than the tails. When you have this kind of distribution, and when the mean is so close to the median, you can use the mean as a typical value, as a representative value of the distribution. And you can always compute another statistic, which is the coefficient of variation, which compares the size of the standard deviation to the mean. So let's go to Excel and compute plus 1725 divided by 5567, and here we have the coefficient of variation. So when the coefficient of variation is at most 0.3, you can use the mean as a typical value, as a representative value of the distribution. Here we are a bit on the limit. Now let's try with another variable. For instance, income. income is not usually normally distributed. Let's check. We will double click with the right button and we will ask for descriptive statistics. And here we have it. We can see that we have a lot of decimal places. We can overcome this problem by double clicking with the left button and select all the cells with a lot of decimal places and reduce them to 2, for instance. And let's do the same with the standard deviation, and we're good to go. And you can see that here the mean is very different from the median. The mean is larger than the median, which means that there are a lot of values that are very high, that is, that are to the right of the median, and that are displacing the center of gravity to the right. Let's ask for an histogram to check if this is confirmed visually. So we select again graphs, histogram, and we replace age by income. And we can immediately see that the variable is not normally distributed, it's not symmetric, it's not bell-shaped, its right tail is much longer than the left tail. So here you have the indication of the mean and the standard deviation. So the mean is about here, and we have a lot of concentration of small values to the left of the mean and very high values, albeit with lesser frequency, to the right of the mean. So in this case, it would be far safer to use the median as the typical value of this distribution.